My name's Jim Prosser-Fenn. I'm one of the directors of Thompson Couplings Limited, a wholly Australian company. It's an Australian invention. It's the world's first and only true constant velocity coupling with no load-varying sliding surfaces. It's a remarkable device that will revolutionise the way that industry operates, the way we build boats and cranes. A big claim? Let me show you why. For over 500 years, engineers have been faced with a simple problem. When joining two shafts together, how do they couple them together in such a way that when this shaft rotates, this shaft will rotate at exactly the same speed, despite the fact that they are at an angle to one another? The current solution is this device. Invented in about 1932, it's the coupling that is currently used in the front wheel drives of most vehicles in operation today. It consists of a shaft rammed in between 6 balls, which are held in a little cage, so that when the shaft moves in relation to the other shaft, these balls skid along grooves inside the cage. Now, it has a major problem associated with it. And what's that problem? Friction. This is also a shepherd joint. It has a little boot on it, and that boot is full of grease. When you turn it at 0 degrees, of course, it turns beautifully. As soon as you start to put an angle on it though, it gets much harder to turn. In this particular instance, let me show you what happens when you try to freewheel it. Simply can't do it. The friction stops it immediately. Friction equals heat. Heat means lost energy. Lost energy, of course, is more fuel. As you can see, I've replaced this coupling with the Thompson coupling. With the Thompson coupling in exactly the same configuration, watch this. No loss, no friction, perfect constant velocity. Saves fuel, saves energy, beautiful. The friction that devils these joints has another problem, creates another problem. It means that they are not good for high torque applications. Torque, of course, is the twisting action. And if you put a lot of torque through these couplings, they heat up enormously. This one heated up to 192 degrees Celsius. It's very, very hot indeed. I wouldn't be holding if it was that hot. In those sorts of applications, we have to fall back on the old universal joint, or the cardan joint, invented about 500 years ago. This joint has a major problem. It is not constant velocity. In other words, this shaft and this shaft do not rotate at the same speed when this coupling is at an angle. Let me show you precisely what happens when these shafts are angled to one another. On the top of these discs, I have placed some blue tack to indicate that they are marked together. These discs are the same size. If I move this disc around, you will see that the geometry of this coupling has actually caused this piece of blue tack to move out of alignment with that pointer. That means that as this shaft rotates, it actually accelerates and decelerates in relation to this driving shaft, and that results in vibration. And the vibration causes immense problems for the machines at either end of the shafts. It also wastes energy. See how this unit rapidly stops revolving? Wasted energy equals wasted fuel. The Thompson coupling, on the other hand, has no such problem. Spins freely, runs quietly, smoothly, no wasted fuel. Very efficient. These old style CV joints have another problem. They can't tolerate axial load. If there was something suspended from this coupling, such as a helicopter, and that coupling was rotated, eventually that shaft would pull out and of course if it was a helicopter that would be a major problem. The Thompson coupling, on the other hand, can tolerate axial load. This particular device has 1.5 tonnes of cement suspended from it. This Thompson coupling is rotating at 350 RPM, suspending 1.5 tonnes of cement from it, and as you can see, it is smooth, powerful, durable and efficient. The Thompson coupling will enable the construction of helicopters with 3 blades or more to have a fully teetering rotor head, and that will result in less vibration, less dynamic load and a much safer helicopter. In addition to being more durable, more versatile and more efficient than any other constant velocity coupling in the world today, the Thompson coupling has another feature. It is far safer. Let me demonstrate. In this apparatus we have a good old universal joint lined up. Now at its normal operating angle, and I'll just try and get it down to such an angle, it's fine, runs nicely. But if it gets out of that alignment, it will immediately start to kick and injure somebody. And if you speak to any farmer with a PTO shaft, he will tell you how dangerous they are. A truck driver will tell you if the shaft snaps or the coupling gives way underneath his truck, it will thrash out the underside of the truck, perhaps rupture fuel tanks, injure people. With the Thompson coupling in the same apparatus, let me demonstrate. You run it down to the same angle at which I had that other coupling, no problem. I let it go, no problem. The Thompson coupling is safe. It will not knuckle, it will not lash, as will the old style coupling. This will save injury, save serious damage. It's just a remarkable device. The Thompson coupling deserves the term revolutionary.